My opening slide.
Yeah, slide is there, so good to go.
All right, so tell me when the guys start now.
Yeah, you can start.
Okay, so I'm Robert McLay. I'm the chief cook and bottle washer of Lmod. I've been working on Lmod for over 10 years now. So I'm going to give a brief history. I'm going to assume that everybody in the room has heard of modules and occasionally have heard of Lmod. Is that a fair statement?
Yeah.
Yes, so. Okay, so I'm going to talk. This is really going to be an advanced topics kind of thing. I thought since everybody should be fairly familiar with Lmod, or at least modules, I thought I'd show some interesting features about Lmod itself, things that you might not easily or know about. And so I'm going to do that. But I'm going to give a brief outline of what I think are the major features, a little history, and then go into advanced topics and mention some things I'm thinking about. So Lmod reads modules that are written in TCL or Lua. It has the one name rule, which means you can only have one version of GCC loaded at a time. It supports a software hierarchy, but it's not required. It has a it has a way to remember all the module files, or as many as you want to tell, system module files say, and that means you can do things like a fast module avail or a fast module spider. Modules can have properties, things like, is it built for a GPU or a mic, or is it alpha, beta, or deprecated or something? Lmod supports semantic versioning, which means that 5.10 is newer than 5.6, which is not the way it would be if you just use lexicographical. It has support for families. So you can have only one compiler loaded, or one MPI stack loaded, or one Python loaded. Well, but if you have Python 2 and Python 3 on your system, you could, if you wanted to, prevent people from having both of them loaded at the same time. You can also track what modules are being used. I think this is an important feature and one we use a lot to figure out what people are using and what we can deprecate. There are many other features, ML, collections, hooks. So you can tailor Lmod to work the way you'd like your system to work. Collections, that means you can have a default set of collections or a group of modules that you want to be either a startup, or you say, I want to load modules, restore GNU, which gives you a whole bunch of GNU stuff, and then switch to Intel or whatever. So you can have collections. And ML is, I could wax hours on how wonderful I think ML is. If you haven't been exposed to ML, ask one of your colleagues who has and tell you why they can't give it up. All right, so that's a big list of some of the things, the features that I think are important in Lmod. A little history, short, one slide's worth. The original version of Lmod only supported a name and a version. Lmod 5 supported a category name version, so you could say compiler GCC and a version number. Lmod 7 supports name version, so you could have the name of the module is Intel IMPI and the version is 64/1801. Okay, so I'm going to now talk about some of the features I think are helpful in using Lmod. Suppose you want a module you want to remove, but you don't want to do it immediately. You want to contact only the users that care. So there's a file called the admin.list, aka the nag message, where you can put a message in that says this module is going away, or this module has a problem, please use something else, or whatever you want in a message. And only those users who load that module get that message. So you don't have to send out a blanket message that says, please stop using XYZ version 2. The format of the nag message is discussed in this on the Lmod documentation. There's support for pattern matching for either on the module name or the file name. Okay, Another recent feature to Lmod is depends on. So instead of trying to, so let's say modules X and Y depend on module A. So you could have said, you know, that X and Y have prereqs, which is module A. But depends on handles this very nicely. So if you purge load module ML, obviously, which means ML and a module name means load that module. ML X means load X, and then unload X, it will load A and unload A. If you purge again and load X and Y and unload X, A will be retained. If you load X, Y, and then unload them, A will have been loaded and unloaded. And then if a user loads A, X, and Y, and then the user unloads X and Y, because the user requested A themselves, A is kept. So that's a convenient way to manage and not leave a bunch of modules lying around that were dependent. And I know that modern versions of EB support this, right, Kenneth?
Yes.
Okay. Since EB makes it so easy to generate lots and lots of modules, and many sites use a single location to store these kind of files, you may want to allow them to stay, but you don't want to overwhelm your users with a huge list of modules that are, you know, 2 or 3 years old. Maybe you'd rather than use the most recent versions. So you can hide modules, and through a system module RC file, there's a standard one, or a user model RC file, you can say, you can include a new statement, which is hide version foo 123. It's hidden from avail or Spital and keyword, but hidden modules can be loaded. Sites can either use them to be for deprecated modules or experimental modules. Users can see the hidden modules with a module -- show hidden avail. Sites must explicitly list all hidden modules, and there's no pattern matching. So Ward provided a hook that allows you to use pattern matching. So there's an isVisibleHook where you can use when you want to do pattern matching. So you are passed in the full name, the short name. So the full name is GCC / 7.2 or something, and SN would be GCC. That's the short name, and FN is the file name. And there's a isVisible is passed to you. So you use whatever rules you want to set the isVisible to true or false, and that you can then mark which modules you want to be hidden. And if you want to, there's a fully work example in contrib, more hooks, site package as an example. Okay, so here's something that came up in somebody I'm working with at the University of Texas, TACC. These people are big into Singularity, and they want to supply a huge list, like 8,000 containers, which do a lot of bio package stuff, bow tie and all those kind of packages. And we are not we have a small but growing number of biologists people who want to use those apps, but we don't want to expose that huge list to all of our users. So, the bio people are the one that tend to have the one that I know they have the largest, but any group might want to have this. But you want to opt in for these modules. So you'll say something like module load bio container or bio packages. And so people who don't load that module won't know about them at all. They'll just see the bio package module. And everybody who wants to opt into those just loads this meta module, which exposes this. And the cool thing, so let's say bio packages is the meta module, and among the thing it does is it extends the module. It extends the module path. I don't know if this shows up. Prepends module path to the list of where these bio package modules live, but you can also extend the cache file. So you don't have to have a cache file that includes this dynamic, this huge tree of modules. You can have a separate cache for just that. You can create this file called, it doesn't have to be called, some file that's similarly named descript.lua, and it, which has to match where this bio packages says. And you can give it a directory and a timestamp file, and in this format, in this Lua, define a Lua table, you can then dynamically expand the module path to include this huge list of packages. And because the trick is to not let Spider know about prepending to this module path. So Spider won't see this prepended module path, so it won't walk that. But a user, when they load it, the mode won't be Spider, and so they'll extend the module path, and then the cache file will be there, and so it will just be there, and you can see all these modules. They'll see them, the people who want all these bio package modules in these containers, and then when they unload this module, the whole thing disappears. So it's a nice way of, if you have collections of modules that most of your users don't want to see, you can hide it. And this all works just right now. No changes required to Lmod.
Robert, one small question.
Yes?
Why is it important to not prepend to module path in Spider mode? Is that to prevent these modules to end up in the general cache?
Yes.
But then what if they do module Spider on, say, Bowtie? They will not see those modules, right?
Correct.
Okay.
Correct. So, it's a trade-off.
Is there a way to force Spider to pick up on the packages?
Well, you can do that, but then you're now here's the problem. Well,
so I guess it's actually Alan's question, but what we're asking is there a forced Spider mode that will jump around this check?
No, at least there's no way to do, if you want that, then you take out that if statement, if block, and just put a prepend in there, and it would just work. But then having this, then it would be part of the cache system.
Then it would always be visible.
Yep.
Yeah.
So you either are on or off.
Yeah, that's clear.
This is most sites may not need this, but for this particular case where there's 8,000 modules listed, it is hiding it from people who might want to know about Bowtie. But I think it's a useful trick. But sure, if you want it to be part of the standard package, then you don't need to do this. Then you just use whatever you've done, and you don't need to have a separate cache file. This is a way. The reason why this exists is the way our file system works. We have what we call the work file system, which spans multiple systems. And so we want to be able to provide this container, these set of things to all the systems that support work, which is everything now. But we don't want these containers to be, loaded by everybody. So this is a convenient way for us to do that.
Okay.
Oh, did I skip something? No, that's it. Okay. Well, I wanted to make this short, so it's short. So here's some idea. This actually discussion with Xavier. One of the complaints that if you have many TCL files, .version files, or .tcl, .module.rc files in your module tree, and they're written in TCL, that every time Lmod sets up an interpreter for each TCL file. and I want to look to see if there are ways to improve the speed of this. One possibility is to optionally combine the TCL and Lua interpreters together into one package to speed up performance, and this will be used to parse the .version, .modularc, and TCL module files. I've only thought about this. I don't know how possible it is and whether it speeds things up at all, but it's an idea I'm looking at. I'm hoping that it will speed up the sites that have lots and lots of .version files. So conclusions, you can find the latest version of Lmod at GitHub. The last stable version is at SourceForge, and the documentation can be found at lmodreadthedocs.org. So I'll entertain any Lmod questions.
Okay, any questions on Lmod in the room? Or on the chat, maybe? Not on the chat either. No, there don't seem to be any questions for now.
All right, well, give me a minute to
switch to XALT.
Switch talks. Oh, let's get back to here. How have I lost? Oh, there it is. Okay.
Yeah.
A way to move this.
You can start when you're ready.
Okay, I am ready. Okay, so Kenneth let me steal some time to talk about Lmod and XALT. So I'm going to talk about the other project I work on, which is XALT. And it's a way to track HPC usage by a job level collection. XALT is trying to figure out what's running on your system. It was a National Science Foundation project. It's a census taker, what programs and libraries are run on your system. It's currently running at lots of places, TACC, NICS, University of Florida, CAUS. There's some work going on at Livermore. And it integrates with TACC, which is another way to get detailed performance counters. And you can get commercial support from Lexis if you like. So we're trying to understand what your users are doing. So what programs, libraries are your user using? What are the top programs by core hours, by counts, by users? Are they running their own programs or built by somebody else, either the system or by another user? Are the executables implemented in C, C++, or Fortran? So since if you build under XALT, I know the linker that, what compiler you use to link the programs, assuming you use one. So I'm assuming that main is written in whatever compiler you use to link with. You want to track the number of MPI tasks, the number of nodes, track threading through OMP num threads. The history is that Mark Fahey and I both separately came up with independent packages, and then we combined forces to combined Alti and Lariat into XALT 1, with Ruben joining a little later. And then once we finished the funding on the National Science Foundation, I finally extended it to XALT 2, which the earlier versions only tracked MPI programs. Now we can track all programs. The design goals are to be extremely lightweight, to provide some provenance data. How is your program run? What libraries, how many use what libraries or what applications, and then we collect the data in a database so you can do analysis. The linker, XALT wraps the linker, or finds the linker, wraps the linkers to tracking of executables. We provide our own LD command, which then intercepts the user's link line. It generates code key value pairs. It uses trace map option to LD to find out what .os and SOs were part of your executable, and this is transmitted and collected into a JSON file, which can be transmitted via the file mechanism or syslog. I'll talk about that more later. And it also can add code that executes before main and after main completes. And then this can be transitioned to a database either by writing to files or sending data to syslog, and you can either collect it using the database I provide, or you're willing, if you want to take the JSON, you can stick it into any kind of system you want, like Elasticsearch, Logstash, and Kibana. So since I know the author of Lmod, I can get Lmod to provide some useful information. So Lmod Spider walks the entire module tree. It can build what I call the reverse map, which maps from path to modules. So I can map both programs and libraries to modules. So if I have a path like the one that shows to some HDF5 module or HDF5 library, I can map it back to which package it came from. And this is also helpful if you want to do function tracking. And if you don't run Lmod but run tmod, you can use it. You can still use Lmod to build the reverse map without making users switch to Lmod. I mean, and you, so you're not required to have a reverse map. So if you don't want to do this, don't want to run Lmod at all, or don't want to have some way to generate this, then you can just plain live with the paths. And that may be sufficient for most sites. But I like to think in terms of modules. I don't really care where they're located. So I like this mapping between paths back to modules. One of the problems with XALT is that it's running in the user environment. So at least the data collection side or data generation side. So you got to protect XALT from unexpected changes in the user's environment. So the way that I do this is by remembering the LD library path that was there at configure time, and also set the path at configure time as well for all the internal executions that happen with XALT, and which I call C++ programs inside. And so this protects me from the user doing something bad to my environment. And by setting both LD library path and path, I can avoid that. So all I got to do is get it right once at configure time, and then the user changes won't affect XALT. So what's the point of collecting this data? So we had a case where we had a lot of people using large memory node, and we figured out that they were a lot of particular chemistry application, and by using TACC stats, we were able to show that they did not need to use the large mem queue. They could instead use what we called reduced weightedness. Instead of asking for all cores, they could ask for half the number of cores or a quarter the number of cores, and double or quadruple the amount of memory each task had. And that meant that they could run in the normal queue and not clog up the large mem queue. So tracking non-MPI jobs. As I said, originally we only tracked MPI jobs by hijacking MPI run or IB run or S run or whatever. Now we use an ELF trick to track all jobs, all programs. So ELF is Baroque. Among the things you can do is you can define some functions, and then these stat adds. You can add a function to the init array or the fini array, and the one that in the init array, any of those get called before main, and if the program completes, you can call anything in the fini array will run after main completes. Now, XALT also adds in a signal handler, so if a program segfaults or whatever, I've hooked it in so the fini will get called as well. But since you only get one signal handler per signal, a user can override this. This C code is compiled and linked through the hijack linker. It can also be used by LD preload. By default, we only use LD preload, but can do both. So as long as your program is dynamic, not completely static, then if you set LD preload, those things are read and those things dynamically get added to your program. So if you have any dynamically linked library and you set LD preload, then XALT will hook into your program and get called before main and after main. But for static binaries, you have to include it in the executable. So depending on your site, you can have it be built into the executable or just be set by LD preload. But by default, I'm only using LD preload. So the advantage that XALT has is that it can track all programs that run on your system. Every CP, every move, every quick call to Python. And I don't want to do that because I'll get overwhelmed with the data. So I only want to track, typically I only want to track some executables on the compute nodes, and I don't want to get overwhelmed by the data. So the idea is I'm not going to get everything, but I want to get a flavor of what's going on. I want to know what's going on at least to some detail. It's sampling. It's like this, what the pollsters do. I'm going to collect enough data to really understand what's going on without having to talk to everybody, every single person. So you can tell tracking only when you want it to. You can control where it runs. So particularly, you might only want to track what's going on a compute node, or you can also, based on path, I want to ignore everything that's in bin or user bin. There's an issue about standard error getting closed before the fini gets run. So Lmod takes care of, XALT takes care of that. Lmod has nothing to do with this. But we've got sampling for non-MPI programs, and this is all site configurable. We use Flex to compile in the patterns. These regular expressions control what to keep and what to ignore. There are ways to control this. There's accept lists, so I want to accept certain things like, things that are in user bin or bin. I want to track Perl or whatever, but I want to ignore everything else. And so here's a configuration file that says 3 things. So you can control what pattern of hosts I want to be on. In our case, our compute nodes are always started with a C, 3 numbers, a dash, and 3 more numbers and something else. But you could have any other patterns that your site uses. Here are the executables that I want to track. For example, I want to keep DDT, but I want to skip anything that starts with a /user or anything that starts with a /bin. So, anything that looks like a Python, anything that looks like R, I want to keep. And those are special packages, which I'll talk a little bit about later. So there are either packages, and keep means I'm going to record them, but there's special treatment for these things that are PKGSs. But anything else I can skip. And then you can also control the what environment you track, and you might want to skip a lot, but keep some things, because the environment can be huge, and that can take up a lot of room in the database. So I want to have minimal impact on all programs. So currently, XALT, at least in my testing, takes less than 1/10 of a second. Only and all non-MPI programs only produce an end record. So currently, XALT produces something before main and after main. So it produces a start record and an end record. But for non-MPI programs, I decided I'm only going to get an end record because I want to be able to sample. So this is site configurable, but these are the rules that we're using. So any program that takes between 0 and 5 minutes, it has a 1 in 10,000 chance of being recorded. Between 5 and 10 minutes, it has a 1% chance of being recorded. And anything longer than 10 minutes gets a 100% chance of being recorded. So now I can track things like Perl and awk and sed and gzip, etc. Or at least get some flavor of how important they are in our system. And then use the fact that I know what percentage, what chance I had to get that to get an estimate of how much they're getting used. And it's only an estimate, but it tells me a lot about what's going on in the system. Okay, so now this thing called these PKGs, these packages, we can track things like R. And so we want to know what libraries, what packages are used by R. So we can do this by having code that runs as part of your R and then generate something. And this will allow us to know that, used R, I'll know used R because you ran the R program, but I'll also know which packages are used. And I'm working to support Python and MATLAB later.
Robert, can I ask a
yes.
question? So
Yes.
in your previous slide, you said that you're looking at awk usage, gzip usage. How can you do that if XALT2 does not wrap anymore the launcher? So how do you do that?
So that's what this was all about. So what I do is I have a .so, which contains these init functions and fini function.
Yeah,
and I set LD preload to point to that .so. Then ELF automagically combines those into a single executable. And so you can hijack things. You can do all kinds of things to ELF program if it's a dynamically linked program. Then you can dynamically link in stuff that the user knows absolutely nothing about.
So any application actually can okay. So non-static link applications you cannot get it, right?
That's correct.
Okay.
But except for a cray, I don't know how to make. Well, on our system, there is no libc.a, so there's no way to make a static application on our system except for the cray. So I tried. It's pretty hard to make a static binary. And under most modern Linuxes, even move and CP are dynamic.
Okay.
So,
okay, thanks.
You should have seen Victor's face when he realized what you were doing. It was cool.
okay. So yeah, so we can track Perl, awk, sed, etc. Obviously, I'm not getting all of them. I mean, for any of those that take less than 5 minutes, I only have a 1 in 10,000 chance of getting them. But but at least it gives me a sample of them. And I know I have a friend who some of you know, Peter and Georg Rath came up with a tool which is somewhat similar to XALT. And because they were dealing with a system which had mainly a bio shop, and most of the programs they ran were awk and sed and those kind of programs, Perl. And so they wanted a way to track that. So this gives us a way to do that without overwhelming the database. And then also I just said we can support tracking packages. So we've got this running right now for R, and we're looking to add it for Python and MATLAB. So as I said, XALT knows about all programs that run. They don't have to be built with XALT. So commercial applications are things that were built on the system, or things that, anyway, won't be linked with the XALT linker. But if you have the XALT linker, this program, or XALT, puts in what I call a watermark, which tells you information about the program. It finds out who built the program, on what machine, and what modules were loaded. And there's a program called XALT extract record, which is supplied, which will find out this information. So here's a piece of what this looks like. In other words, it tells you what time, what the epoch was. It also gives you the date, who built it, what the compiler was used, the path to the compiler, what the host is, what version of XALT generated that. So this information is in the executable. It was built with XALT. If it wasn't, then there's no watermark, so I don't know anything about who built it and when. But a funny story, we were benchmarking for the new proposal, what we call our Frontera proposal, and we were competing or trying to do benchmarks that were run on the Blue Water system at NCSA. And so one of my colleagues tried to run an executable, and it failed. And he ran this program and discovered it was built at NCSA and not us. So that was kind of cool. Some new features is that XALT can know if a GPU was used. This is an optional choice. It will know if one or more GPUs were accessed. There's no performance data, and this comes from Scott McMillan from NVIDIA. And also, XALT can now track what's going on in a Singularity container. You just provide some sets of environment variables, Singularity underscore something or other, LB preload and whatever, and it can write to syslog or use a file transfer. And this is also from Scott. And so one of the things that this pointed out to me was typically, many systems are running Red Hat style systems. We run CentOS, but containers are typically Ubuntu. And even though they're using whatever kernel you use, and they're essentially doing a fancy chroot, so they're running in a slightly different environment. And so where CentOS put things and where Ubuntu puts things are slightly different. So I've modified the way XALT works so that instead of hard coding the paths at configure time, I'm now using a limited path to control what things get run where. So that's been a new change to XALT as well. So if you want to get the reverse map, you'll need Lmod. And so there's a pointer to where to get Lmod. And then you can get the latest version of XALT at GitHub at XALT, or you can get it and you can get the documentation at XALT Read the Docs. Okay, I'll entertain questions on either Lmod or XALT.
Any questions? All right. We walk up to John, who has a question which may be related to R.
Hi, this is John Day, and I don't really have a question. I actually wrote something exactly like XALT a couple years ago, but I am plugged into the Unix kernel, and I get an event for every single exec call. And unlike yours program, like my code doesn't get inserted between the start of the program, so it's a stack-based thing where I'm, picking up this giant fire hose of events off of the kernel. And my first filter is the UID. So anything that is run by root, I don't care about. So I throw all that stuff away. And much like yours, I also output key value JSON straight to syslog and collect all that. And it is pretty interesting what you can find and detect and patterns of behavior on the cluster. But I never thought of looking at the loader. I just kind of curious if you have comments, if you've looked at just going straight into the kernel and grabbing kernel execs.
I haven't looked any. Once I just found the init. I mean, the advantage of us hijacking the linker is so I can put among the important things is this build UUID. So I can connect. When I start a program, I look to see whether this watermark is there, and then this build UUID is available to me. So that way I can connect the execution that was run and where it got linked. So that's really why I want to do that. If I hijack the linker, I have the advantage of doing that. And that provides some useful information. Among the things I really enjoy is by doing this, I can back out what you linked with. So that gives me an idea of, C, C++, Fortran, questions. I guess it could be Go as well. Anyway, although I think Go produces static applications. Anyway, this gives me a way to get this information. And you're right. The problem with XALT is you've got a supercomputer generating all this data, and trying to find ways to get useful information out of it without being overwhelmed by the fire hose is really the problem. But yeah, send me some links for if you've got anything written up on your stuff. I'd like to look at it.
Okay, he's nodding, so that's coming up. It sounds like this may be a way to fix the lack of being able to track static binaries, because
no, I can. Well, I'm not sure you. Well, I don't know.
You can link static binaries, but only if XALT was hijacking the linker, right?
Correct.
Yeah.
But as I said, I'd like to know how many sites are producing static binaries.
Yeah, that's a good point. I certainly don't have, I can't unwind as much data as what you have. What I get is just given to me from the kernel, so what's in the proc file system. So
and you're right. And
so I have UID, parent ID, I have the command line. So it's not as valuable. I have to tease that apart to try to figure out what users are using from that.
And this gives me a way to track things like, the way we understand our system is typically by the module use data and by XALT. And what was nice is that we were able to say to, when we were proposing a new system to the National Science Foundation, we said, these are the kind of, we know what percentages by users, by SUs, core hours, that our system uses. So we didn't have to base on surveys and stuff. We just know.
Yeah.
But we learned, it's surprising what we learned. Every time somebody asks me a question, I say, oh.
Robert, so how do you actually get XALT in production? Do you have a module for XALT, or you get it in the path of our users, and then they cannot really unload anything? So it's always by default enabled.
So what we do is we have it's a module. And I actually like having it as a module because occasionally XALT can cause problems. It's rare, and it gets rarer all the time, but something happens. And so it's a module. But on our system, every user, by default, every user gets the TACC module. And in that TACC module, we have XALT. So you have to explicitly unload the XALT module, or you have to do a lot of extra work to make sure that XALT is not there. And as I said, I'm not going to collect everything. So if some users don't have XALT, that's okay. Most of our users are so unsophisticated, they don't know what modules are. And so it just happens. But since I'm sampling, I can't get everything. I need another system almost as big as the system I'm trying to measure to try and keep track of it all if I did that.
And can you comment again why you don't want to take like very small job? Why you don't want to track that?
I'm sorry, ask the question again.
Why don't you want to track very fast jobs?
Because, well, so what happened to me was, on one of our systems, somebody was processing image data to do dark energy studies, either dark matter or dark energy, I'm not sure which. Anyway, each program took about 2 seconds. And in 2 hours, they generated 5 million entries. And it took me 5 days to read in those 5 million entries. And that's just not feasible. I have to read it in less than a day. So I just cannot track everything.
And do you have any plans to drop the MySQL support to something like Elasticsearch?
You're not required to use MySQL as a database collector. XALT breaks into 2 pieces. It generates JSON, and then I provide a tool which uses, which reads MySQL. But Kenneth and I, in a day, he did most of the work. I watched. I got an ELK thing set up. So if you understand ELK, it's quite easy to do. My problem with ELK, at least my limited understanding of it, was it throws data away in, I guess you can dynamic control, but it throws away data in like 3 to 6 months. And so that's not something I want. The other thing is that I don't understand, simple databases don't seem to, and again, this is me speaking with limited knowledge. I'm sure somebody else knows more than I do. XALT generates on many different one-to-n relationships. So an executable has 1 to 10 to 15 to 20 shared libraries. That gets complicated with databases that are designed to be fast. I've never found a good way to do both. These time series databases are great, they're fast, but they don't really support one-to-n relationships, or at least I don't know how to do it. So the answer is, you can do what you want. I provided one of those choices, but I haven't had time to look at ELK. It certainly would be something that we could also support as well, because it's just going to syslog. So syslog could be processed multiple ways.
Okay. Hi, I'm Chris Mesas. I'm thanking in behalf of Victor. He's just nodding now. I'd like to comment on the issue of the static binaries. At least at our side, we see a little more frequently than in the past that people request software built from written in esoteric languages like Go, Rust, D, then with LMVM support and stuff like that. And instead of providing then the entire trunk which goes with it, we rather install indeed a static binary if it's at least performant. And I don't know how other sites here would react to this attitude, but at least we would actually require then that a static binary is can be installed and would like to see it tracked.
Fair question. As long as, then to track it would, my understanding is that you can't use the LD preload trick, but you can set up XALT to use the linker and insert code in there. And those all work because, or at least as far as I know, it works. I've yet to see a case where it doesn't. Where as long as the XALT's LD is there, then it would be tracked. But I don't have my solution is limited to those two methods.
Hi Robert, it's Damien here. I have a question, kind of best practices kind of question. So you have these two methods in XALT, hijacking the linker or using LD preload, but I guess both have their downside. With we use EasyBuild, so there you would have different linkers spread around on the file system. So if you hijack the linker, I guess you would have to make it aware in each one of these installations.
No.
How does it work then on that case?
Well, you have to be using Lmod, but Lmod supports a thing known as dynamic paths. So the XALT module has a path that's more equal than any other. So every time a module gets loaded, it puts the XALT binary path, the XALT path, the XALT bin path ahead of everybody else.
Penned, but with less priority than the path of XALT kind of thing. Yeah. Okay.
Yeah. Otherwise,
has higher priority. Exactly. So we have.
Yeah, it has a higher priority.
Yeah. Okay. Okay, that makes sense. And so for people that are using XALT already, because we aren't, how is people normally using it? Are they using the hijacking of the linker or LD preload? A mix of both, because one requires that you have to recompile your stack, and the other you use.
Well, no, you don't. As I said, you don't. The only thing you lose is the ability to get this information. You don't have a watermark, but otherwise the name of the executable that ran. So you don't have to rebuild anything. You lose a little bit, but
you have LD preload set, right?
Yeah. You still have to set the LD preload. So that means that if you have a static binary, and it was built pre-XALT or XALT wasn't loaded, then it will not be tracked.
Okay.
I think part of the answer is you would enable both to make sure that if you're hijacking the linker and you're building static programs, you will get that information. XALT will pick up on it because it's included in the binary basically, and it will spit out all the data. And then LD preload you use for things like CP and move and things you haven't compiled yourself but are dynamically linked. So Lmod picks up on those as well, which whatever information it has, and that way you get most of the possible data you get. But the only thing you lose is static binaries that were built without XALT being around. That's the only thing you lose. Yeah. I had a question as well. Somebody else has more questions? Okay. One thing you mentioned is that you now have already support for tracking R libraries that are being loaded basically or imported. And you can do the same for Python, but it's not there yet. Is that right?
Yes, I haven't had a chance to work on it, but it's not. I know how to do it.
You know how to do it, yeah. Just a matter of.
And I know how to do it for MATLAB as well.
Right. It's just a matter of finding time. And what about Perl? Same mechanism?
I don't know. I could track Perl. Or I think it's, I don't know whether I have the ability to go into the use thing and have my own wrapper in there that could generate records.
Depends on whether the Perl runtime gives you a hook or something.
Right. I'm dependent on some sort of hook. So every thing like R, MATLAB, and Python, there's some trick that you have to know, and each one is different. But once I know the hook, then there's support for collecting it.
Right. Okay. Sounds good. Any more questions before we close this talk? And switch over to the last remote one. Do you have a time frame in mind for being able to track Python imports?
Sometime this year. It's not hard.
Yeah. Okay. Okay. Thank you very much, Robert.
Thank you.
I'm actually at work and not at home with a computer. I know that works.
Okay, the streaming has started, so you're good to go.
Okay, thanks. Okay, welcome everybody. So my name is Oldeman, and I'm one of the EasyBuild maintainers of the weeks at this point. And I'm working at ComputeCanada, namely a certain cluster organization, regional organization called Quebec, and then for McGill University. And since there's been a lot of discussion about Python, I'd like to present our setup and a few things that we're working on upstreaming to the main EasyBuild repository that could be useful for other people too. Well, there's some things we're doing completely different, and I'll give it for your information. You can learn from it, or maybe use it at your leisure or not. So the overview of the talk is to give a quick introduction to our infrastructure and software stack, which shouldn't take more than 5 minutes because I want to focus on Python. Introducing our Python module, like modules really, but it's just 4 variations of the same thing for different Python versions. And then how to use a single module with multiple Python versions, and virtual environments and wheels. It's just basically our way of dealing with packages. So the motivation of setting up our system, like a common system for academic clusters in Canada, is that we now have bigger national systems replacing many smaller clusters that we used to have. Basically, every self-respecting research university used to have their own little cluster, sometimes bigger, sometimes smaller. But we now have bigger clusters, only 5 of them, which are supported nationally. So there's many universities now who no longer have a data center, but they still give support, and they have analysts working for them, but they just don't have the hardware on site. So the big systems that we're having now, there's a cloud system, University of Victoria, that came online about 2.5 years ago. Almost 2 years ago, we've had Cedar and Graham coming online. They're like general purpose clusters. They have many CPU cores and various GPUs. Niagara came online last year. It's a homogeneous system with 60,000 CPU cores. It's 1,500 identical Skylake nodes with 40 cores each. And last but not least, we have Beluga, which is sitting in the data center right next to me at the moment, about to be handed over to us by the vendor any day now, which has almost 35,000 cores and 688 GPUs, which is 4 GPUs per node on those 172 GPU nodes. And the V100s, which is a great advantage to people doing AI, because they are really, really very fast on half precision floating point numbers, like a factor 8 or so versus the P100s that are on the other clusters. So we wanted to have a common interface, so when people switch between clusters, they have pretty much the same module view. There is internal differences in the clusters. They could have OmniPath or Mellanox InfiniBand. They may have a different file system, some have Lustre, some GPFS, etc. But we want to have like a common user experience. So we need a distribution mechanism for the software, which we do via CVMFS. And also we'd like to open the possibility that the underlying OS can be different. So it should work on not only CentOS, which both clusters are using, but also Ubuntu, Fedora, etc. And we do that via a middle layer that sits on top of the OS in a prefix. We're using Nix for that, but we're also testing another solution named Gentoo Prefix because we had some issues with Nix. And then we use EasyBuild, of course, for the automated installation of the the more scientifically oriented packages. And then we use Lmod with a hierarchical structure to make it scale well and not to have a module fail with 10,000 modules. So this is our design overview. At the top, we have the EasyBuild. Below that, we have a few EasyBuild generated modules around Nix profiles, which seemed like a good idea at the time, but we're mostly not doing it anymore. We use it mostly for GCC, where we use a Nix GCC that sits below the EasyBuild modules. And then all the kind of boring stuff, but including glibc, all the tools make bashcat, all the GNU utilities are in a Nix layer. So we basically filter out all these boring dependencies of libraries that people that are just dependencies for other software. Many sites make them hidden, but we just put them in a gigantic middle layer module, which is Nix, and we're testing Gen 2 as well. Then the gray area of some very system-specific libraries like CUDA, Lustre client libraries that we can distribute on CVFS, but we don't have to. And the OS kernel, of course, needs to be local, and some restricted software tool like VASP that doesn't allow us to redistribute it in any way, even if it's internal. So CVMFS, I don't really have to talk about what it is because it's been extensively covered in David's talk already. So I'm just going to skip this slide. Nix. So this is like the middle layer that we provide via module. Using Nix, we prevent like the low-level modules that I just mentioned. We have like a long list for the filter depth configuration option for EasyBuild. So many things are just not, even if we take an upstream easy config, those dependencies are just not taken into account because we just provide them via Nix, maybe slightly different version, but it's usually new enough. We have an updated glibc, so many people can download like random binaries, then change the put patch elf on the downloaded binary and it will work, and we don't have an outdated glibc like you have on CentOS generally. And we can just then add any library that we like or not, depending on sysadmins. Nix has hundreds of OS packages out of the box, but we had some drawbacks. Namely, Nix is very self-consistent in itself, but it requires that users of Nix also have to use Nix, like random developers on our clusters. To take full advantage of it, would have to use Nix themselves, which is an unrealistic expectation. So basically, we say, what do we need Nix for? We basically do it to put things like common dependencies in a prefix. But there's a simpler solution to get that working too, which is Gen 2 prefix. And that's matured quite a bit over the last few years. It's actually also available in the CERN CVMFS as quite a very mature system of building software using eBuilds. I think maybe EasyBuild can learn a bit from it too. It doesn't mean we completely throw away Nix. There's still a Nix module on the Graham cluster, which is full-featured, and people can install their own software in Nix. And so we just make it separate. We say, okay, we don't use Nix in a read-only fashion anymore, but we keep the Nix full-featured for people who really want to use it. So in terms of statistics, we have a team installing software. So now we have thousands and thousands of modules. Over 2018 was a bit of a bump towards the end. October, November, that was my colleague Maxime Vassonneau recompiling a lot of things for newer toolchain, GC 7.3 and Intel 2018. And you also see at the bottom like a lot of Python wheels, which I'll get to in a moment. Like we have about 1,500 of those. So to get to the core of the talk is the Python module. So there's been some discussion about moving Python down to the GCC core level. We put it even lower. We put it in the dummy level. So basically, we use the system compiler, which in our case is GCC 5.4, which is basically the Nix compiler that we started with. And it's pretty much a module that looks, the EasyConfig looks a lot like Python bare EasyConfig, except we have a couple extra options. One is our mod extra paths, which sets a Python path, which is just one file in it, which I'll get to in a moment. The second thing is that we set the pip config file, is that we have a customization for pip, so that people can set up their own virtual environments. And using this pip config file, it will download wheels from our local wheelhouse instead of downloading them from the internet. The last I just mentioned, what we install in our Python modules is a very short list of extensions. We only have 5 of them. This is like the minimum that we need to install wheels, really. Setup tools, pip, virtual env wheel, and our read line is just handy in general. So the 2 lines that I make in dark red are the things that I get to in more details. First, I'll get into the mod extra path, the Python path, what's that doing? So in that we have one file which has the name site-customize.py. Now this file is documented on Python documentation, and it just is loaded by default when you start Python. And so it can add things to sys.path, which is basically an equivalent of Python path, but internal to Python. So what it does is that it looks at an environment variable, which we named EB Python prefixes. You name it anything you like. And then combines EB Python prefixes with the actual Python version. So it takes the path from the EB Python prefix, then adds /lib/Python plus sys.version, which means Python 2.7, Python 3.5, etc., /site packages. And then it adds those paths to the standard paths using site.add site here, which means it does all the processing that's needed, like PTH files and other things that are in those directories. Why do we use this method and not use Python path like the standard modules do in EasyBuild? There's 2 reasons. One is that Python path is not version aware. Like if you set Python path to a Python 2 module and you start Python 3, then Python 3 will still try to use the Python 2's Python path stuff, and it will just not work, and vice versa. So it's very hard to use if we have multiple Pythons available at the same time, which is the case because, well, there's always the system Python 2 that sort of floats around in the background, and Python path affects that too. The other problem with Python path is it overrides virtual envs, that we sometimes saw that people were installing things in a virtual environment, but also had a Python package module loaded, and the module Python path was overriding what they install in their virtual environment, which is kind of counter to the expectation. They expected the virtual environment to be more important than the module that was loaded. So the EB Python prefix is designed to be to sit at the lower priority than virtual and installed packages. So how are we use EB Python prefixes? This basically allows us to have a single easy config and module for multiple Python versions. So instead of having the Python version in the suffix, which is often the case in the standard modules, like you have boost /168.0/Python 363 and /Python 2715, etc. We have a single boost module, and then depending on which Python you load at runtime, it will look for that particular for the particular Python files. Which is kind of the way it happens in standard Linux distributions that don't have modules. So what we put in the easy config is a new option named iterate build dependencies. This name is up for discussion. I just put in a PR on the framework where I basically added a new dependency parameter called iterate build dependencies, which is on top of build dependencies and just iterates through a bunch of dependencies and use them at build time. It's the similar mechanism as you can already do with build ops and config ops. You can iterate through them, and then the build is just happening n times with different modules loaded. And then in the software that uses Python, we put in mod extra pass equals EB Python prefixes. And now if it's an extension, we could put this kind of mechanism into the EasyBlock as well. So that's something that we're working on. So how this works in practice is that a module may set in this module file prepend path, EB Python prefixes, and then for side-by-stack module, it puts the prefix /core/side-by-stack 2019A, and then Python 2715, when you start it, it will look in that directory /lib Python 27.7/size packages, and Python 363 will look in the Python 3.6 directory. So it's all, when it's working, it's pretty straightforward. Just you have to hope that other people don't use their own site customized.py, which would override ours. So far, that hasn't happened. Now, the iterate build dependencies is something that I just recently implemented. We used to hack around it by just putting explicit module load statements in the easy config files. That's a bit of a hack. So I'll try to contribute to do it properly. This also iterating through dependencies is a bit of an intrusive change within the EasyBuild framework. It's not a lot of lines that change, it's just that it means that the modules that are loaded are not always the same, and that breaks some expectations, and so I need to go through iterations to get that pull request right. As an aside, there are some drawbacks of using dummy Python. They were discussed on the mailing list and on various conf calls. Generally, whether you use TCC or Intel compiler to compile Python makes no difference, because Python by itself is slow in any case. However, there was one issue that was found by Damien, and he put it in the GitHub NumPy issue, namely that exponential trigonometrical functions like sine and cosine aren't using the faster libimf in NumPy, even if NumPy is compiled using Intel compiler. Even if libimf is linked in statically, it still will use libm because Python is using libm, and the symbols that are loaded in memory come from libm. So even if libimf comes in, the symbols aren't overridden from the main Python. The only workaround is to use a LD preload. No, there are multiple workarounds, sorry. So the workaround is to use LD preload, which is a bit cumbersome to use. Another one is to just ignore this, because most programs don't spend 100% of the time doing exponential and trigonometrical functions. Another way that Jülich did it was you use a hidden Intel compiled Python executable that you just use whenever you load some Intel compiler. Another way which will help make this problem go completely the way of the dodo in the future is that newer glibc have a much faster exponential and trigonometrical functions. Hopefully this will only get into glibc on clusters maybe in about 10 years, but we work around it by having the prefix. I read there is some work going on in the glibc community to actually separate some of the user functionality to make this stuff easier and more earlier available on clusters to make it independent of the system specific part. But what they did is to relax the precision of certain of these functions. It used to be at 0.5 ULP, which is extremely good precision. It's like the ideal precision. But what they did to get such good precision is that in some edge cases, the glibc actually went into a multi-precision path where there are certain values that you can feed to X in glibc where x takes like 20 times slower than a value that is 10 to the minus 20 higher or lower than the slow value. But took some people completely by surprise. So they've made glibc a little bit less precise, from 0.5 to 0.509 ULP, like a rounding error. But now the performance is competitive with libimf and sometimes even slightly faster. And libimf, by the way, has much worse ULP numbers, like 1, and there's even a fast path which is like 5 to 9 ULPs. So it's still very good. So that's that issue, and it's sort of plaguing the decision whether to go with TCC Core Python or Dummy Python. Then the other thing that we're doing is to provide virtual environments and wheels. So we basically do not provide a full Python with a lot of packages built in, but we only provide a base one and a SciPy stack module for the most commonly used packages like NumPy, SciPy, Matplotlib, etc. Everything else goes into wheels, well, except for a few things that are hierarchy dependent, MPI for Pi, and some packages with Python bindings like OpenCV and Boost. But everything else goes via virtual environments. So that's like a common case. People use TensorFlow, PyTorch, scikit-learn, all these things. They all use that via wheels. And we actually recommend people to set up virtual environments dynamically in their job script, because most of the nodes have a local file system, often an SSD. And they said, okay, load the Python module, then set up your virtual environment dynamically. And by using pip install with a requirements.txt, you can basically say, okay, these are the exact packages I want to load. And they just get installed on local file system and it runs fast. And then the requirements text comes from pip3. So you basically set up a virtual environment in your home folder first, like a test environment, and then you do pip freeze, and basically it can save the virtual environment, and then you can reproduce it using pip. Now, the wheels are not without their issues. So we've run into various issues, but we basically have solutions for them. So what we do is that we have an Arch-specific configuration file for the wheels for pip, which is called pip-avx2.conf or pip-avx512.conf, etc. Which then refers to two directories, two wheelhouses. One is the Arch-specific and one is the generic wheelhouse. And it sets prefer binary equals true. Because what happened in the past is that sometimes pip was installing a package from the wheelhouse, but it has some dependencies listed, and then pip is very dynamic and thinks, oh, the requirement is that package X must be version 0.20 or newer. Oh, but I see that there's a version on McPy that's newer than the wheel that we have available, and it just starts downloading stuff which it didn't download the day before just because McPy has updated something, which is something we want to prevent because it's not reproducible and it also takes a lot longer. So we set a prefer binary equals true, said, okay, we want to prefer the binary wheel. Only if we don't provide a wheel, it will fall back to downloading from McPy. Prefer binary doesn't mean that we download binary wheels from the internet. The binary wheels from the internet are usually called Mini Linux 1, which are not very good wheels for our HPC system. They're very generically compiled, basically meant to run anywhere, but they're not very optimized. So we basically disabled them, and we can do that by putting a file named manylinux.py in the Python path with a line manylinux 1 compatible equals false, and then those wheels are not downloaded. The last note is that all our wheels, they sit at the core level, which gives us some challenges because sometimes weird things happen with lib standard C++. With sometimes a scenario that we load Python. Python is not compiled with C++, so there's no lib standard C++ in memory yet. then some Python package loads, which is linked to the TC640 lib standard C++. Then we load package number 2, which is compiled with a different GCC, and we get into symbol errors because everything, all Python packages are using .sos that all live in the same memory space. And so we get symbol errors. So we are now avoiding that by basically trying to recompile as much as we can with TC730 and just using the same lib standard C++ anywhere, but we can't shield ourselves against users compiling with their own GCCs. So at least we know where the issue is coming from. In the end, maybe we'll just make sure that the newest lib standard C++ is always used, because this library is actually backwards compatible. The other way is, of course, to use a hierarchy throughout so that you cannot load a Python wheel compiled with TC7 if you load the TC6 module, but we found it a bit too strict, and it means we have to build a lot more wheels for no good reason. So that basically concludes my presentation here. I'd like to credit the other members of the Research Support National Team in Canada, led by Maxime Vassonneau. We're responsible for setting up this software stack, documentation, ticketing system, and some of the helpers for the NICS experts on the sideline, Tyson Whitehead, Salvilio, Arthur Prentice, and my colleague Casey Chen, who started it as an experiment, so we're building on that. Also, thanks to EasyBuild, we took a lot of clues from other sites. University of Kent, of course, a lot of ideas from Jülich and Robert Speed, who's also Canada, does not work for ComputeCanada. So this concludes my presentation. Thank you very much.
Thank you, Bart. Let's see if we have... Yeah, go ahead. Let's see if there are any questions in the audience. If not, I do have a question. So you're working on the iterative build dependencies thing in framework. Well, one thing that I immediately start wondering, but I haven't taken a close look at the PR yet, is why introduce a separate parameter and not just like extend the scope of the current build dependencies one?
I actually used that method of extending build dependencies in my first batch, but I found it was getting messy very quickly. It means if there are common build dependencies, you basically have to mention the common build dependencies twice or 3 times. So suppose there is a common build dependency, like whatever, CMake or something like that, and you put that in the iterative build dependencies, then you have like your like Python 2.7 plus CMake, then Python 3.5 plus CMake, then Python 3.6 plus CMake, and you have to mention it. You have to mention the CMake 3 times, and then the framework would have to detect the duplicates too to avoid loading the module 3 times. Well, maybe loading module 3 times doesn't hurt, but it's still a performance issue, even if it doesn't hurt.
Right. So what you're doing now is the ones listed in iterative build dependencies, you load the first set, and then in the second iteration you unload the first set and load the second one, and you...
Yeah, actually this is one of the issues with the PR I'm fighting with, because unloading it, I haven't quite figured out how to do that. So basically what I do is to save the environment on the first iteration, and then I restore the environment on the second iteration before loading the modules.
Yeah.
Properly you would unload the modules, but complicated.
Okay. And then are you aware of any other changes that we would have to make to make sure we can have a single installation that's compatible, let's say, with multiple Python versions? I mean, we would need to get the script in there, the site customized somehow.
Yeah, that's all part of the Python module, really.
It's in the Python installation, yeah.
Yeah.
And then that's it, or?
Well, there needs to be somehow to get the EB Python prefixes set. So that could be part of the Python extension EasyBlock.
Yeah, just like a flag that you say this is a multi-Python, or
right.
I guess you could auto-detect that if you have iterative build dependencies with Python in it, and that implies that you need to set.
Yeah, but you even want to use it from configure make easy config. So I'm not sure how that would work exactly. But,
and then it needs to go in framework.
Yeah.
You just make it the general easy config parameter in framework where you can enable it.
Right.
Or you just add the auto detection in framework.
Yeah.
We can figure it out once we get there.
Yeah, these are all technical details. I think the most difficult part is to get that iterative build dependencies. The rest are fairly simple tweaks that, I mean, I can already just put them manually in the easy configs like I showed you. Just to get it more higher level and get this automated, that needs a few more tweaks, whether in easy blocks or in the framework.
Okay. Can you go back a couple of slides? A question popped into my head, but I forgot what it was. If I see the slide again, it'll return.
Okay.
It'll return to me. One more. One more, I think. Was it here? I forgot what it was. Maybe it was the next one. Yeah. Yeah, I guess I forgot. Or the comment you made about you could have the problem that users have their own site customized.py, and that gets in the way of making this actually work. Is there any way to avoid that from happening at all?
I'm not aware. I think users can always cut themselves in a sense. Even first, I can modify Python path and put all kind of things in there. So, but it could be that some software is dependent on customized.py